Hello, I'm back. So, let's center the camera and we continue our work. So, I've reopened Unity and it actually did not change that the heart is not beating. Let me set up the microphone bit for a bit. Okay. Should have maybe waited until going online. So, I think this is better. Because the microphone was getting in my way. You stop. Okay, now we are ready to go. Okay, sorry. Okay. So the heartbeat is still not beating. We have the shader graph, which shows up that the heart actually should beat. Okay. So what here? The heart really shows up the heart should beat 100%. And okay, that was what we were googling. We were googling some heartbeats. Wanted to go into Unity. So let's look at the heart. It's wobbling. But it does not beat. So as a test, we are going to create a new game object. Put our sprite on it. Okay, put it here in front of the camera. This is just a test, so I don't care that the size is all over the place. And now let's set up the material to our health bar material. And it really doesn't beat. Okay, it doesn't beat. It doesn't beat. It's a problem with our shader graph. It's not another component. It's really a problem with our shader graph. Okay. So we have proven that the problem lies within our shader graph. So what could cause this? If we set to pi, let's copy the old value. We set to pi to 0. It's not going to beat. So that could be an explanation. If we put beats per second to 0, it is also not going to beat. And here's a multiplication. That will not make it not beating. This multiplication won't do anything. This will only affect the size of the beat. And these two won't do anything. Let's skip those. And let's take all of the graphs here and put it to the other side. Because it's a little bit cramped in here. And so these, how do I get you outside of this node? No, it's not a subgraph. Ungroup. Okay. Control U. Okay, let's ungrouped. Okay, could you maybe not open the history every time I do this? Thank you. So we now have this here. We also did not add any comments yet. So this is looking a little bit weird. Let's set these values up. Okay. Let's save the graph. And nothing should have changed inside of Unity. The heart is still not beating. So yes, we did not fix the problem. Now let's look at the graph settings here. I don't have any idea what could cause this yet. Let's look at these bloodied and blood effect fields. I don't think we need these. No. So let's clean this up first. Okay, we later have to take a look at these graphs here, because they are also displaying some kind of beat effect, but we're not applying this. I think we never use these color nodes. So let's delete them. Would be nice if we could see where we are using them. No, we don't see that. Let's delete all the things that we don't need. Fade is not used yet at the moment, but we will need it later to fade in and out the sprite. When we are doing it in dialogues, for example. In dialogues, the heart is going to be faded out. When someone is talking to you, the heart is going to be faded out. So this is why we need the fade. Let's look at noise scale. And we're using a UV map. But I think it's not applying any kind of scale to the noise. This is Voronoi noise. So we can also delete that, I guess. Yeah, it didn't change anything. So we still have the same problem. We haven't touched this at all here. And it's not working. Let's not change the periodic shift of the sinus and see what happens. And that did nothing. That did nothing. Did we set up the main text? Yes, we did. Fade is not doing anything. These are all working. Only this one is not. Now the next thing that we could try is to increase the scale of the beating. Let's for that expose the scale parameter. So create a new float, beat scale. It's going to, oh. Beat max scale, going to be our new parameter. And we're going to set this to 2 right now. And we have to drag it in. I'm not sure where we set this. Now with this max scale, we can change the size of the beating. Let's see if we maybe have a problem with the size. The size inside of this preview is maybe different from the size in the game. What am I doing here? And it actually did something. But it directly multiplied. It's just multiplying with the scale. So I think what's happening here is following. At this moment that we add here something, it's always 1. And then it multiplies 1 with its scale. This is why we have such a weird result. So the output value here is always 1. This is going to always put out 1. No, it's 0. This is going to put out always 0, which implies that something is broken. Ugh. That's not good. And I really have the feeling that it is this 2pi value. I'm going to make it exposed because of that. And let's see what 2pi is. Oh, now it is 6.2. And it started beating again. So it is actually our exposed value that is not working. But if you do not expose this value, it's setting the value to 0. This is a bug. This is a serious bug. And what can I say? This is just not right. If this is not exposed, this should be its default value. Override property declaration. Okay, let's try out different modes for this. No. So if you don't want this to be if you don't want this to be set to 0, what can we do? Nothing. Okay, let's Google this. Unity shader graph load set to 0 if not exposed. And I don't think that I will find anything. Okay. As I said, I don't expect any results out of it. So we have to bite the bullet and make this exposed. And this is actually really bad. Just how much time we lost because of this feature right here, that if you don't expose this value, it's going to be set to 0 and you have no way to set it. I don't know why they would do that. It makes no sense at all to set this to 0 if you cannot change the value. Maybe Unity guys can explain, the guys from Unity could explain this to me. There's some kind of sense behind it, but I think it's just a bug. I think this is really a serious bug, and I don't no, this might be not just with the version that I'm using of Unity, that this is not working. Okay, so enough of all of that. Let's create a box. What is this called? A group. For all of these nodes here. So we just wasted so much time for such an easy bug. I can't believe it. We're going to make this into one big group and call this hard scale. And now we are going to ungroup all of these. All of these. I'm going to ungroup these. You might be thinking, why? That doesn't seem to make sense. We're going to create a new group and call it heartbeat beats per second generator. Because all this does is create heartbeats per second according to the values we set. Then we are going to apply this to the heart scale. This is all we do. And here in this function right here, we are going to also use the values that we generate out of here. So how are we going to do that? So we are going to see where this sine wave is plugged in. And plug in our generated values. No. Okay, let's do this again. It's not using the right pixel. That's annoying. That's why I prefer coding. But it's not taking the value. I think because we are using a vector 3 or something. No. No, we're not using a vector 3. I have no idea why this is not working. Okay. Just to be a little bit faster. Come on, add it. Add. It's just a value. Come on, you can take it. That's weird. Let's try to get it straight off of sine. Also not taking it. Maybe because it's from another group or something. Man, that's so weird. Let's ungroup this. And try again. No, it's not taking our values. That's weird because this sign is literally connected to an add node. This is bullshit. So what do we do wrong? Let's disconnect this sign and try. Now we can do that. It doesn't make sense. I guess we just found another bug. This is clearly a bug. This is clearly a bug. Now can I connect this to this add node? No, I can't. So I can only connect this to one other group, I guess. Who does this? Who thought that would be a good feature? It doesn't make any sense at all. Now this is from another group. If I ungroup this, is it going to work? No. I have to cut this, put it in here, put it in there. But now I can't put it in here, I guess. I don't get why. I don't get why. So I can't use the same group again. Maybe there's a workaround. I do the same thing with 2 ads. And now I can plug in the second one in this other group. But I don't understand why this is not possible. Why isn't this possible? That's really weird. This really feels like a bug because I don't see any reason. Let's think. No, no. I don't see any reason why you can't connect this to different kind of nodes. Maybe this node is because I made this one today has another ID, and these ones use some kind of a legacy function. I call bullshit. So what we have to change now is, if you look at the movement inside of these graphs here, these are simulating blood flow inside of the heart, and now they're pumping when the heart is extending. But actually we want to do this the other way around. So what we have to do here is, for this one, okay, because we don't want to do this one again, going to multiply this. Oof. No, I don't think this will work. We multiply this with a negative value. Oh, it does work. Now we have changed it so the pattern here on the heart, that is supposed to be some kind of vein pattern, is pumping every time that the heart is getting slower. How amazing is that? Now, let's see if this still works in the game. Yes, it does. It does work. Still think we are not doing enough wind direction. So we can easily now change these beats per second, and it will look just the same. We can also change on the fly how big this heart is going to extend. We later see, oh, we did go over the top there, or okay, that's not enough. Let's do more. Let's go bigger. Let's go faster. Oh, he's dying right now. Let's go back to our real UI instead of the test UI. And we activate the animator. And after that, we are going to set everything up so it really works. Right now we have a lot of things disabled just for testing, but since we fixed our last bug, we can start working on this. Okay, let's test it. Now I think the jitter from the material here looks like it's too much. So let's scale this back. And that's over the top scale. Okay. Yeah, he's really beating. Okay. So I think this is going to be next to the one. I still think that jitter for some reason looks weird. Okay, that's it. This is it. I think for today, this is as much as I want to try out. I might do the adjustments later in the when I still am unhappy with this, and you don't never know when you're going to start to be unhappy with something. I still can adjust all these settings here, but let's stop this and get going. So the next thing that we want to do is we're going to remove all the images, and then we are going to have some errors. So the first thing that we want to do is We've changed a lot in this player UI. See, there's a lot of overrides right here. Let's apply them all. Now we are going to use this in every level. Let's open the prefab. And we have these image components. Let's remove all of them. Now we are going to use the sprite for this. And so this still uses an image. Let's remove that image. And there we have it. Now, what's this going to happen? This is going to generate some errors because these scripts here are trying to get what the hell happened to the camera? It's not centered anymore. So these scripts are trying to get the health UI, the image component. And we have to rewrite it so it does use sprite renders. So let's get rid of all code that says get image and use sprite renders. So these are image components. We can't have that anymore. We have to change this. We also need this sprite right here to have the same pivot point as this sprite. So let's copy this pivot point and insert the values. Because this heart is supposed to be behind the other heart. Now we have to readjust the position of the self UI here. So we can do just like that. And this text is not at the right position. Okay, and already fixed some things. Now we're going to change this image into sprite. Oh, sprite renderer. Let's maybe use sprite renderer. Might be useful later. So now this is generating a ton of bugs. Yeah, this is what we need to do next in the shader graph. Because we have this fill amount, and this fill amount means when we have taken damage, we want to set the amount of health that is a blood that we are displaying inside of the heart. This is why I use this shader graph. Just to have it enabled. Okay, I need to think and speak more clearly, sorry. In the old version, I used the image component and used it to fill and unfill the heart with blood. In the new version, I need to do that with the shader graph. Okay, sorry. I actually made a mistake there, sorry. That explanation just was not very good. I think this material is not used. Ooh. No references. I think this is not used. As I said. So I think I'm thinking about deleting this material item. Yeah, it's an unused material. Delete that. Now, let's go even further and find our old graphs. Also rename this to player status UI. I want to see what this is. Oh, this is some kind of sprite component that handles sprite. So we don't need to change everything. That's weird. Okay, it's finding an image. Yeah, it says sprite, but it actually isn't. Org. Well, we can just change this. As render. And I think this will just work. That's fine. It will just work fine. Except we can even do more. First of all, we don't need to set up a private variable. We are only using this in the start function. So never mind. Delete this. let's make this into a hybrid. So we don't need to set everything to be in a sprite render. And we can save by some time if we define this to private can define an enum, public enum, public enum. We have to define it. So in enum is something that you can set up with different values. I actually have an enum, a good enum reference in the character script. So let's look that up because I'm not 100% sure with the syntax. Sir, do you have an enum? Yes, you have. Nice. So let's define this enum. Yeah, image type. And we have two types. Only two. One is sprite. The other is image. And we're going to make this enum public. Is this possible? So let's see if we can set this enum image type inside of the inspector now. Because that would be really amazing to just have a switch which you can define what you want to do. Oh, we don't. So I think it's this component here, but unfortunately we can't define this enum. Ooh, that's so unfortunate. Because I would just like to have a toggle here or some kind of menu where I can select this is sprite, this is an image, where I can't do this. Let's Google this. Unity public enum. Oh, I know. Because first, let's put this here, down here. And maybe write this in with uppercase. Then public image type, image type. Is this possible? No. Okay, this is already used. Or is it? No. Let's see if we can set up this image type. Yes, we can. We now have, we did it. We now have a list. We can say this is sprite. This is an image. Why did I never do this before? This is something that would be so useful in so many kinds of situation. I should really keep this in mind. I love enums. I love them now. Really. Okay. So Why do we do this? Because now we can just ask if we are an image or a we can now ask if we are an image or a sprite. So case image. Then we enter our code here, which is the kit for sprite, but we're going to change that. Break. Then we have our second case, which is, of course, sprite. And in this case, we don't need to change anything. So let's make this an image again. Set everything up, and we are ready to go. That's as easy as it gets. And if we ever add even more types, which is very, very, very unlikely. Yeah, it's very unlikely that we add more types. But if we add more types, we can just add another case. That's why I'm not using an if-else statement, which, by the way, is a common a common problem with some of the noobs. Some noobs really do this. Okay, now let's copy this code, and in the update function, we will have two functions, one for if this is an image, or one if this is a sprite. So we did set up an image if we have an image. And this is as easy as it gets. We are finished. So we can now just tell the script, this is an image, this is described on the fly, and we are ready to go. So, hope Unity finally finishes. Can you please? Yes. Okay. Now we have to go through every component here. If this has this HUD UI sprite component, we have to check is this a sprite or image. If this is an image, we set this to image. Because I don't care to set everything that was an image to a sprite just because I'm too lazy to change the script. If you change the script, you can just make it modular so it will fit into any case. Now, there is a script here that is named image functions, and I guess we will have to work on that later. And 1039. Thank you for following. Thank you very much. And hello, little drone. So now we can set this up to be an image, and our little component here will do whatever we need it to do. And this is just an effect. Okay, nothing to do here. I need to look into this image functions. And as we see, this is assuming that we have an image. But we don't. Ooh. And we also don't know yet, and I'm going to try it out, if we can set the alpha channel of this HUD with the sprite renderer. Let's try it. Yes, we can. Oh, so that is convenient because now we don't need to set the color, the alpha channel with the shader graph component. Why this is nice for me? Because I've already set up some code inside of this image functions, which I need to remove now. And put inside of this. And I need to set this up to be able to also take a sprite. So how are we going to do this? We are going to declare this public enum image type. Oh, I think because we declared it here and it's public, we can use it in the image function too. We don't have to have. I don't think we have to declare it again. And all the other things here, this seems to be very old code. All the other things are actually private. So can we just import it? Yes, we can. Can we do it? Maybe not this like yeah. No, I want to import it right here. Can I do this? No. Oh, I've forgotten how to do this. Let's just do it like this. Let's just do it like this. It's a little bit more convenient. Oh, I think I know how. I think I know how. We put it outside of this class like this. Is it now publicly, globally available? Yes, it is. Yes, it is. Nice. So now we have this global defined image type, which is a little bit weird that it is defined here in this class. Maybe I should put this into health UI. Yeah, let's put it into health UI. If I have any problem later with this, I can still find it just by right-clicking on it or something. Think go to implementation. And usages. Yeah, here I can still find it. No, cannot. I do not find where it is declared. This is interesting. Okay, that's not convenient. So let's put it back into a class that actually uses this enum. Because if I'm ever going to search for this and want to add more types, which I'm probably not going to do, but Just for the principle, let's do this. So this has a component main image, which it is never going to use. Oh, and it searches for every image in its children. So let's see. Okay, in this case, it's not finding anything. Let's just look where this script named image functions is used. So right now I only have found one script that component that uses this. 2. Vane's background and Vane's top. That's it. So let's look again. Why do we have this? Okay, I think this is set the every sprite to null. If we want to record for trailers, if we want to record for trailers, we're going to set every sprite to null, because then if we are trying to fade in or fade out any sprites and they are set to 1, we are still not going to see anything. I think this is a workaround, this HUD sprite here, just so that we can make tutorials. Videos faster. Later, when we will record some skills, we are going to use this component. So this needs to be there. And then we have this component which gives us functions for the dialogue, and it will then fade in and fade out our components. So you know what? Since we are never going to use this private image, we don't need to set it up. However, this function here is very, very bad. It's in every frame trying to get its component if it's fading in or out, which is going to generate a lot of calls instead of Unity. So let's not do this. Let's actually do this instead. Okay. Now we want to use our nice switch case. Let's just copy this structure right here. And put in one line of code. Okay. And now we can do the same, the switch case, in inside of this padding in and padding out function. Okay, in case if we have an image, we are going to execute the code that we just already have. And we don't need to care about this because we know it will work in the future as well. Let's care about this if we have a sprite. So for this, we are also going to take this code, but we're going to take the sprite render here. Okay. Now let's just use this sprite render here. And I think because image and sprite render, it works very similar. We can just reuse the same keywords. So we don't need to wrap our head around anything that we actually don't really care about. We just want to do the same thing. We just want to do the same thing as we want to do with the images. So we don't care about anything, just copy the code. Now it will work. We have now just to set it up that these are sprites and the others are not. And I think because it's only on it's only used on sprites, we have to set this to sprite. Oh, it's set to sprite by default. We don't have to do anything now. I think we never use an image for this. Okay, everything seems to be set up. Let's look at this help UI script. Okay. I think we have to change everything that has an image inside of it. So this is sprite render. And as you can see, it's really sprite render image. They're very similar. You just have to change their names and immediately it's working. So let's define two variables for this, because this is also making the very unfortunate decision that it wants to find objects every frame. So this right here, never do this. This is disgusting. I have to put this right here, and we are going to make this into the awake function. And okay, this is right, is all right. I don't know why this is here. I have no idea why this is here. So instead of finding sprite renderers every frame, just set them up one time, which is going to increase our efficiency. So we just have to do this the first frame. Don't have to find them every frame. And we are also going to rename this to not exactly sprite renderer, but S renderer. Because I like S renderers. It doesn't like me doing it this way. Whatever. We still haven't set up a function inside of the shader graph that can fill up our art later and empty it when we lose health. So we will let this leave this commented out. We are going to do this later. And now let's try to play the game. And I expect something to not work. It changed so much. There has to be a bug. Okay, no bug. That's interesting. Okay, I really expected it to not work at all or something. Yeah, that's interesting. But I don't like that the text component there is not moving with the heart. So I have an idea. Let's attach the number to one of the bones. So how are we going to do that? There's this bone here, and it's moving with the animation a little bit. We're going to attach this current health text to the bone. Now, I think in this health UI script, we're referencing the health text. Oh, it's just globally finding the text. Okay, so yeah. That's interesting. So you now see that the number right there is moving with the heart a little bit. I think it looks a little bit funny though, because it's even using its rotation. I mean, this is amazing. Just look at this. And the game later, it's going to look like this. Yeah. I mean, we could also increase and decrease the size of the text a little bit. But let's just keep coding until we later maybe change the numbers a little bit up. I think this really looks funny. Okay, so we have all these functions set up, and now we have to get back to our shader graph. So let's start looking at the shader right here, and we defined this shader in our graph right here. Let's open it up, and the last thing that we need to do is make a function so we can fill or defill, empty. Some pros call it emptying the heart. So if we have a lot of health, we are going to have the heart full. If we don't have a lot of health, please make it empty. And clicking on this, so nothing is happening. Open in shader editor. Maybe did I open this anywhere? Oh yeah, I have it opened on my second screen right now. That's why I couldn't see it. But weirdly enough, it didn't put itself on top. So we have to do something. And for this, we are going to edit the alpha channel. Currently, we are using the sample texture and using its alpha. And if we edit this, we can change how the heart is displayed. So how can we do this? So this is first let's visualize this. This is a two-dimensional matrix. It's a two-dimensional matrix, and in this matrix are numbers. There's a lot of numbers there, and each number is for each field of our sprite. And to modify our matrix, we want to set only the first columns of our matrix to 0. And then we want to have a function where we can tell him how many columns we want to set to 0. And if we say 0, it will be every column will be set to 0. If we set it to 1, then we want no column to be set to 0. So I have no idea. Let's look into the matrix. We have some matrices there. Now these matrices here, they are very useful for blur effects, let's look what we can do here. Yeah, so what you normally can do with this is you can set this to something like that and apply this to every pixel, and you're going to blur everything. Now, unfortunately, this is just an out. But this is not what we want to do. We want to change our metrics. Does it tell us what is coming out here? Can we get the information? Let's look into sample texture 2D. Unity, shader graph, sample texture 2D. And alpha is outputting just one float. Okay. That's weird. The alpha component, also called W, is just a float. So this is not what we want. So what we actually want to do is to edit it in the base color. Or do we? Now that's a good. Or make a sprite mask. Oh. I think it's lying somewhere, because I'm very sure that with all these information there, the this API wants to tell us that these are all floats. And with this, if we put out all this data here from this sample texture, RGBRA, we would not be able to construct an image. You would only get 4 floats. This would not be sufficient to have an image. So it's lying. It's not right. This one here is a lie. I don't know if only this is a lie, but I assume it is a lie. Now we can take this alpha right there and just let's take the add node, take this in, and we actually see immediately what this is putting out. And we see this is not one value. This is actually a 2D graph. This must be a matrix. This is not just a float that's coming out of there. So if we would subtract something, it would now fade out. And if we add something, it will be brighter. So what's happening right there? So you might say, oh, it's just one value. No, it's not. It's not. What is happening right there? It's adding this value to every pixel in this graph. And it doesn't get us anywhere. Except for we now know how this actually works. So we have a float now for every pixel. Now maybe it says something. Returns a small vector for D value for use in the shader. You can override the UV coordinates using UV input and define custom sampler state and sampler import. So I think this doesn't say it. And I have a crash in the Explorer. Okay, that's better. Doesn't say it. But they of lag. I can just maybe close some browser tabs. Yeah, I closed shader graph, but I still have a lot of lag. This is really disgusting right now. Okay, let's save the project and hope that the lag has stopped. And I'm really not happy about this. It's really, really worrying me, as if something is wrong with my PC. I will have to actually contact the place where I work right now, because I need to, a working PC. Let's build some team. It should not have happened. Sorry. Okay, it maybe was because I was had Chillergraph open for a long time. Let's just hope that this won't happen again. So how do we do this, that we apply a mask to this? I don't have an idea. I could just randomly try some shader graphs nodes, but and just Google this. How to create a fill function that looks nice. And here we have the solution. So what do they do? Ah, they use a tiling and offset node. I guess this does something in this case. I'm not sure about this part here. This is needed. I think we can just plug in sample pen texture into this. So I'm going to. So what's happening is they have this fill level. This has an output, and it only has a y coordinate. And this is using an UV map and offsetting it as a rectangle. Okay. And I think this black rectangle is then multiplied with the image. And that's how you create the final image. I think they plug it into the alpha. Yes. They also use, he also uses albedo. So this is a very good example how to do this. Yeah. Okay, let's do this. Let's just straight up copy this. So, what do we need first? It's fate. Not with T, with D. Then 1 minus. What does this do? Range. 1 minus. Okay, I want to Google what this does. Returns a result of the input in subtracted from 1. Okay. That's an interesting note. So if we put, yeah, okay, we don't need this. So this just sets 1 minus. If fate is 1, then the output will be 0, and we will fade out. Okay, I guess. Is it? No, I think I want to have it the other way around. If this is 0, I want it to be 0. Okay. Oh god. Let's just copy it. So I think what it does is, if we are 0, we are going to output 1, and we have fate 1, and it's going to output 0. And I'm not sure if I'm happy about that. Let's see about that later. How it's plugged into tiling and offset. So we also need the vector too. Put this in here. Put this in here. Okay. Use a rectangle. Put this as a UV map with the height and width to 1. And now let's play around with our fade value here. Yep. So if we set this to 1, it's white. If we set it to 0, it's black. So it actually is white. We want this one minus. Okay. I'm a little bit confused that they actually made a note for this. If you can just use a subtraction note like 1 minus. Must be very common to use this note. Okay. And I'm actually not a fan of this. Because if you now say, okay, but I want 10 minus, if you're using some, or 100 minus, if you're using percentages, yeah, suddenly then you have to extract this note. I'm not really a fan of this. But interesting that it exists. There must be someone who really uses this and thinks this is actually a good case. Okay, now let's create a multiplication node and just straight up plug in our alpha channel and our 1 minus, set them for alpha, and let's see what happens if we fade. Okay, that's interesting. The problem that we have here is the sprite is maybe not reacting as we want to. But I'm not sure if this is just in the preview or if it's also in the sprite renderer. So let's see how this is now affecting the real game. So we have this fade value. And as you can see, we can now fill our heart and defill it on the fly, which is really, really nice. And if we maybe have time someday, we could even try to make something on top of the surface. But for the moment, that's over the top. Yeah, we will not have time to do that for now. This would be something that I would be excited to do in the future. And I think we did a lot today. A lot of really good work. So, the problem is, for the first half of this fate value, nothing is happening. And we can't have that. We want to start at this point right here. And then for the last bit here, there's also nothing happening. We can't have that. Okay, let's fix that. And this time I can't just copy some code. Damn it. I can't do this. No, I actually have an idea. And this is the textile size. We can put in our health UI here. And this is outputting our height and width. Can we put this into a vector too? I guess. Yes. So let's put them into a vector too. We don't want to have them as separate values. And now we have to Now we have to maybe it's here. We have to find out where we have to put it in. No. Okay, now it's not working at all. Because I think it sets the height and width to its textile size, which is going to be a really big picture. So let's maybe put this at 0.5. So if we put it into this tiling here, no, that's also not happening. So we have our width, we have our height. Can we set this as a UV map? Okay, this everything is black. It's also not right. I'm going to look into another shader graph where I did this. I actually used the original size. I think it's the loading bar or the boss UI bar. I actually used the original size to affect the shader. So let's see. So this is plugged into tiling and offset. Now this is then used as a UV map. Okay. I have an idea. No, it doesn't work. No, let's unplug this and think about what we want to do. We want this box right here. We want this. And we only want to affect this area where we have our little sprite. So I think here's a width. And here's a height. No, that would need to be some offset. No. It's not going to work. We only want this rectangle at its base to be around this right here. So could maybe offset this. I don't know. Hmm. Let's Google shader graph UVs, how they work. Just try to get smarter. Okay, what is a UV? UV mapping is the process of projecting a 2D image onto the mesh of a 3D object to give it shape, detail, and texture. This is achieved by putting the texture map to a set of coordinates above the classic X, Y, and Z coordinates, known as U and V coordinates, allowing the 3D object to essentially be painted. What are UVs in Unity? UVs are simply 2D coordinates that are used by 3D applications to map a picture to a model. Letters U and V were chosen because X, Y, and Z were already used and denoted to the axis of the 3D space. So the UV is just some kind of mapping method with coordinates to displays our texture here. Oof. I need to look up something. I think there's maybe a very simple solution to the problem. I think the sprite editor has been set up. Yeah, it never has been tiled. So can we slice it? No. No. Cannot slice it. Custom outline, custom physics shape. But can we maybe slice it? It's just a border. Don't think that's doing anything at all. Let's nonetheless just apply this. And look what happens. Okay, nothing happened here. I think if we set it up like this, then this side of the sprite will not show. And actually this is not even doing anything. Okay, so this border right here, forget it. Okay, let's Google how to set the width and the height of a sprite. And this, what is this? Sprite editor. Hmm. Okay. So it's a little weird that I can't set its width and height right here. That's inconvenient. And in our case, it's really inconvenient. Hmm. Hmm. I don't want to set this to polygon. I hope this doesn't lose us the bone structure. Could set this to multiple. It's just Okay, let's just try this. Now with multiple we can actually have only this void. Okay. Now, does it still work? And we don't see it in the game. Disappeared. Where is it? Okay, it's missing the sprite. Aside from that, it's working now. It's nice. Let's reopen the shader graph right here. Let's save what we just did. And we need to reposition our text right here. Which is weirdly positioned right now. Where are your anchor points? That's odd. Okay, let's just revert this component. And it's really weird what's happening right there. Let's go into the prefab and look at this text. Weirdly enough, we cannot set the rect transform. Like normally you can set the mode. And this is not set to stretch mode. Which is such a pain because I don't understand why people would not use stretch mode. It's a most useful mode if you want to guarantee that the sprite is not some weird place. So you could say, hey, just drag it here to this side. The problem is it's actually way inferior if you do this because it's not scaling. So if I would want to import my game to Android or iPhone, and they use other screen types, or somebody uses 4K monitor. It's not scaling with the monitor size. This is horrible. And want to this. Can you reset this, please? This is also not giving me any options. This. Oh. Can I maybe put this? And let's go into the prefab. I think it's because these are transforms. That's why it has problems setting up. Now let's put it into stretch like it should be. And I want to see if the heart is scaling correctly. That's why I'm going to press play and just try some really weird sizes. Yeah, and the heart is scaling correctly. So if somebody is playing at this size, the heart is still being shown at a quite nice steady rate. So you could ask, but who's playing at such a resolution? I don't care. I just have to make sure that it works no matter what resolution you choose. And aside from that, we shouldn't care. It's a wrong question. The question is, how am I going to do this without without ever having to worry about the screen size? Because I don't want to have adjustment for different screen sizes. Somebody might use a really old monitor, or then there's somebody who uses a 10 by 10 monitor. I don't care. My things will scale, and then everything else won't be my problem. So let's apply these changes, and then open the prefab. The full hard image is not visible. Grr. Why? Can you please be visible? Oh, because the sprite is missing here. Okay, now you go. Here you go. We've put this into stretch mode. Fortunately, Unity decided that stretch mode means we don't want to use anchors, and anchors are actually the nicest way to place object and have them scale indefinitely. Yeah, I don't use top, left, right, bottom. I only use pivot anchor points, and everything else is not my problem. Because like this, then no matter how we scale the object, text is scaling with it. Okay. Let's get back into the shader graph. After a long time, can get back into our last finishing touches. So first, let's look into the shader and look where the shader graph is actually placed, because I think it's not at a good place here. Let's put it into this materials folder here. Okay, where I can find it a little bit faster. Because I'm making this mistake over and over again. Now, if I use fade, it still is not going to apply to the whole image. Ooh. Still not using the texture I want. Ooh. I thought we fixed this already. It actually didn't. Hmm. Now the only thing that we have gained here, we now know the x and y position that we would have to apply, and the width and the height. So we at least got some information. And maybe we can use this. Just maybe. So I'm setting the brightness of my setting here a little bit down. So I really see how much I'm sweating. Okay, let's go for the last touches. So we know our width. We have to put it in here. Know our this is this is width and height. This is our height. This is the width and height only of this texture without all this emptiness. Now we have to apply the offset, and I can read this offset. It says 346 327. That's what the sprite editor is telling me. But is this useful at all? That's a good question. Can we use this as a UV map? No. Can we use this as tiling? Guess not. I guess these values are different from this one. Let's look into tiling and offset. Now the only thing that I don't like too much in shader graph is how these graphs are described. The APIs are not always on the top notch, unfortunately. You can set the UV coordinates of how much of the texture is rendered. So this should be sufficient for the coordinates. No, this is. I'm confused. This is not going to work. No. No, it's not. Let's look into the tiling component. Hmm. Okay. This rectangle here is creating a UV map. We want to put it into this tiling and offset. Now let's try out some values first. I think tiling is not going to do anything here. Just as offset. Let's look into tiling. Only thing is that it's changing the UV. So this is not doing anything. We only can set the offset, and that's actually not what we want to do. And even that is not working as I would expect it to. Hmm. So if we would set this to 2 and 2, the texture is going to always repeat itself. We're going to put this to 4 and 4. It's also going to repeat itself. It's just an UV map. Pixel size node. The generated shape can be offset or tiled by connecting with the tiling and offset node. Exactly what we are doing. Unfortunately, it still doesn't work the way we think it would. We don't want it to be tiled. So let's again go for texel size. No. Vector 2. Ooh, can use this as a UV. And we cannot use this as a texture. That's not nice. I need this as a texture. Oh, this one will be nice for tomorrow. I think we can. Oh, Excel crashed. Oh, it didn't. If I apply twirl to enemy data graph, I will show later what I want to do with this. Oh man, I could cry. I didn't have any idea. What can I do? Hmm. Well, I guess it's time for basics.
About working with UV coordinates in shaders. Let's get started. Before I show you what you can do with UV coordinates in shaders, the first thing that I want to do is show you what UV coordinates are. UV coordinates, also called texture coordinates or just UVs for short, are a convenient way of translating 3D space into 2D. We need to be able to do this because texture maps, like this one on the left, are 2D images, but our models, like this cube here on the right, are three-dimensional. So UV coordinates are the method that we use to define how to wrap 2D images around our 3D meshes. Let's use an orange as an example. It's a 3D object. If we peel the orange carefully, we can keep the peel in one piece and lay it out flat. Now that the peel is flat, it's in 2D space. But if we wrap the peel around the orange again, we've translated that 2D space into 3D. UV coordinates work kind of like that. Each of the vertices in our model, like we can see here on this cube, there's a vertex on each of the corners of the cube. And each of those vertices has a position in 3D space as well as 2D space. So now we can apply a texture to our model, and the 3D software uses the 2D space UV coordinates to know how that texture should be applied. So here you can see in my UV space view, I've got the top of my cube, the front of my cube, the left and right sides of my cube, the bottom of my cube, and the back of my cube. I can do a few interesting things to these UV coordinates. I can move them around, and you can see that as I move them in 2D space, they also move in 3D space here. So I can pan my UV coordinates left and right and up and down. I can also rotate my UVs. And I can scale my UVs. Now this is interesting. As I scale them larger, it gives the appearance that the texture is getting smaller. And as I scale them smaller in UV space, it gives the appearance that the texture is getting larger. And so this is a little bit inverted from what you might think. Scaling the UVs down makes the texture scale up and vice versa. And that's important. We're going to take a look at that in a minute when we get into Unreal 5 and Unity. So in this video, I'm not going to spend a lot of time talking about how to create and apply UV coordinates. That's an art form into itself, and there are a lot of other videos on that topic. But I did want to show you what UV coordinates are, so you'll be able to better understand what's going on once we start to mess around with them in our shaders.
A really good explanation.
All right, let's jump into Unreal 5 and Unity and take a look at a couple of examples of what you and also from 0 to 1 in the vertical as well.
Now this is Unreal. Let's go to Unity. In Unreal, you can also see that they use a very similar approach than Unity for applying shader graphs. Why? I think it is because Unreal Engine did it first, and in my understanding, Unity copied it from Unreal. So let's go to the Unity version.
All right, so here we are in Unity, and you can see that I have my texture sample plugged into the base color and also the emission socket of my master stack. And right now I don't have any texture coordinates plugged in. I'm just using the default UV0 here. And so I get my cube just the same as I did in Unreal 5. And if I plug in my UV coordinates here, just the same as I did in Unreal 5, nothing is going to happen there because the default UVs going into my texture sample are the same as adding the UVs from channel 0. All right, just the same as we did before, if I multiply my texture coordinates by 2, they're going to get smaller. And I'll actually tile the texture twice. Or I could tile it 3 times or 4 times, as many times as I want. And multiplying makes the texture coordinate get smaller as the value goes higher. But dividing makes the texture coordinate get larger as the value goes higher. All right. Okay, and here if I add to my texture coordinates, I'm going to add 0.1. You can see that they scoot over just a little bit. Add 0.2. Now notice there's a bit of a difference here between Unreal and Unity. In Unreal, as I added to the texture coordinates, they were moving up and to the left. And in Unity, as I add to the texture coordinates, they're moving down and to the right. So that's an interesting distinction to keep track of. And so if you're translating shaders between the two engines, you'll want to compensate for that. UV will get our UV coordinates scrolling down and to the left, just like we did when we added 0.2, except for now they're animated. And just like we got in Unreal, if I plug time into multiply and then plug multiply into the texture, you can see that I get a really, really high scaled up value. And so what I actually need to do is add a sine node so that I'm doing the sine of time. And so here we're getting our texture coordinates scrolling back and forth.
Yeah, I think we get it. Now, let's go back into Unity and try to apply our changes here. So we now know what this is. We have to find out. So the width and the height, if it's set to 1, it will be the whole area here. And we have to recalculate this. We're just going to do this with the calculator. Oh, am I? No. Let's create a node, pixel size. And let's put in the main text. Uses as width and height. Okay, now this is not working. Why? Because this is a vector 2. Because size in a texture does not work the same way as it does in a UV. If the UV is set to width 1, it's the whole UV. If And that's not the same thing as in a textile size, where the size is going to be a very, very high value. So we need to divide our main texture size values. Let's put this down here, because we are getting out of space. So let's divide this. Now we should be able to set the height and the width. So we now see this is the actual width and height. We have to apply this separate values though. No, I need to split. And then we can apply our offset. This is not doing what I think it would do. Ooh. Ooh. That's inconvenient. Oh, I think, yeah, because I think we forgot to set this the right way. Yeah, now should only apply this to this top value. That's weird. Okay, this shouldn't have worked anyway. Okay, we now have to find out how we can separate a vector 2 in shader graph. So the more we do in shader graph, the less we know. We're going much more into the basics. So it's actually done with the split node. Okay. And maybe the matrix split. No, it's not a matrix. Something's wrong with this. Can we use this division here for tiling? No. Or can we? I guess kind of works. Now, for some odd reason, it's not tiling correctly. And I think the output values here are bigger than 1. Yeah, they are. So we are going to take the textile size, which is going to be a big number. Let's say it's 2 divided by a smaller value like 1. Yeah, of course, it's not going to work. We have to change those two. Now, what did we create? Now we have this rectangle here. The rectangle actually has divide properties. I think this rectangle here has a wide size. If you offset it a little bit, just like this. Oh, and we don't need this. Okay, we are going to finish very soon. I figured it out. So we can just create a node, add, and this is all right. We are going to use this add node right here and plug it into the offset. So we don't add anything yet, but let's do this, because now we can actually use this to place our box we just created. Okay, this is how we are going to make the offset work. Oof. So where is our offset? We have guessed it now. It's going to be here in the corner somewhere. Here, we do not have the information we need. I'm also not convinced that this division here is correct. So let's look into Unity. Okay. So many questions. How big are you? How many pixels do you have? 2048 times 2048. Let's for a second, just to try it out. Put 2048 into these two values here. Okay, we actually get the same values. It's the same box. Okay, that's interesting. So this is the right width and height. And I have the feeling like this box is a little bit bigger than what our heart is. I can move it just so much and we won't lose anything. Now for the width, this is not so important, but for the height, because this is where we want to fade. We can do this per hand, and I don't want to do this by hand. Of course not. We need to calculate. I mean, just if I show the sprite editor, and you see, if I zoom out here, the heart is, let's say, maybe a quarter, not even a quarter of the full picture, but this box here is way bigger. Something's weird. If this width and height is 1396, it should be bigger than 1/4. So this is not the actual real width and height. It says it is, but what would it be if we set it to its max value? 3000. Okay. Oh, I think there's some recalculation going on. I don't know what kind of recalculation is going on. Discard all changes. So we have our information that we need. This is 3000. This is 3000. I actually don't remember why. I don't remember why. Now we have to get the offset. Let me open the sprite editor once again. Now I think what this is same as these 3 nodes. Let's put them here and plug them in. Let's now use the values from the sprite editor. And this looks very accurate. Now this looks like this is the correct position of the sprite. When we put down this fade, it's fading away. Let's put this to 1. So let's carefully set the offset. I don't know why this offset is not correct. But we now have an indicator where it really could be. And now we are finished. If we put this value down, you can see that it is actually fading away. Oh no! So when I'm starting at 1, it's starting to fade away immediately. But at 0.5, it has already faded out completely. That's not good. I think it's because we're moving the offset too fast. So let's put this back to 1. At 1, it's alright. If we're adding anything, it's immediately starting to fade. We now have to think about how we add this fade value to this division. And I think it's because we don't consider its total size, its actual size. So let's create a multiplier. Plug in this vector right here. And the actual value, and see if it now scales correctly. And as we see, right before we hit 0, we have actually made it. We have made it. If you hit 0 now we have such a small value. 009 is just showing one row of pixels. If we hit 1, let's subtract a little bit. Let's set it to 099. We see at 099 it's subtracting one row of pixels right there at the top. So this is the golden setting. This is everything we need. It wasn't so hard, was it? Yes, it was. So we finally did it. We have all our functions for our shader graph, and it's working. Oh, this was way harder than I thought. Way harder than I thought. So let's select all these shader graphs here. The nodes, sorry, these are not shader graphs, these are nodes. Put them here and create a group. And name this group fill function. Fill function. Okay. Now, last question is, if we put this to 0.5, could we make this surface display some kind of something that is not just straight a line, to have some kind of effect that obfuscate what we are actually doing. Oof. Oof. And I'm thinking at the same time why I'm even considering that, because it would look good. It would really look good. Yeah. So let's just set this up. Noise. We're going to, for example, have Voronoi. So let's see. This is Voronoi with the normal UV. Can set up these cells right here, and we can create a node with the time. Let's make them move. It's not really convenient. Okay, it's also not convenient. I think we have to add more. Yeah, something like that, just as an example. And we want to only put it on top of this rectangle. Ugh. What if you use this? No, this is not going to work. The cell density is going to be very, very small, like this or something. And I think there is a way. There is a way. We just have to do the same thing. We just have to change the height and the offset. I got it. And it's really easy. It's also really easy. I found it. Okay. Now that we have this rectangle here, we're going to add the width, and we're just going to set the height to a ridiculously low value. And we want the same tiling and offset as this one, but add a little bit so that this offset will be a little bit higher than this tiling and offset. So let's I don't think we can just add something to this one. So let's make a new tiling and offset. So can we set it here? Yes. Now we can just raise the bar by 0.1. Oh, we have to apply minus value. So 0.5. Okay. And now if we apply this UV map to this, no. So we nearly got this. Cannot apply this to this though, because it's not expecting such a UV map. Let's create a node and say add. Can we combine those two? Yes, we can combine them. Let's multiply them. So now we only had this part here. This is nice. And now we can add this to our other component. Make this our output. And oh no, we don't see anything happening. But here we go. Here we go. There we are. Now we have an area above this area where we can try to make some magic happen. And we still have to do something, and that is we're going to have to add this UEV map on top. Oh man. Let's copy this. Put it right here. Copy this. Put it right here. So we want to do something like this on top of this. So what would happen if we multiply those? Yeah. So we need to redo this clamp now because it's broken. So instead of this UV here, we have to use this tiling and offset. And with this, let's plug in this. Okay. Think I got it. No. That's not good. What does split do? It's just going for the G value, green. Okay, we don't need the split value. That's not what we are going for. Let's manually put in this value. See what happens. Nothing. So we have this rectangle here. We only want to fade out its top and then go down until the bottom. So I have no idea what I'm doing actually. It's a matrix with a lot of values, and we want the top values to be 0, the lower ones to be 1. Oof. Oof. Yeah, how are we going to do this? And then we want to do some stuff with the top of the heart, so that we don't have an immediate fade to nothing. So we're close. We're close. We have a lot of the steps done. We just need to add a fade. Oh man. Just like this, reversed. This is a UV map. Well, let's plug these values in again. So we want the G. And we now want, after we clamp this, now we want to reverse it. I think we could maybe simple math do something. Let's think about it. What would make... I know something. 1 minus. We're actually going to apply this. Oh, it didn't work. 1 minus betrayed me. In the end, we want to take this value here, multiply it with our end result. Yet we don't have what we need. And the only thing that we need is we need to take this UV map, squish it, and put it on top of the heart. And put it on top of this. It had this. We want to take this and have it on the same position as this little effect right here. Oh, I have an idea. Let's copy this. And as a UV map, can we use... Oh, it's... Oh. Ugh. So, as a UV map, I'm going to use this here. Then plug it in here. Copy these values. No. Unfortunately, it doesn't offset the whole rectangle. It's a little bit weird that the bent rectangle here gets the width value from this split, but displaces, shows this whole area as rectangle. That's weird. Ah, okay. Can't use this. So let's try something else. So what if we create a new node, multiply this rectangle with this UV map. Put it into the split node. Plug it in here. No, didn't work. Okay, why waste more time when we can Google shader graph, fade effect.
Hello, and all over it.
Oh,
To be doing
and I fear this is going to fade the whole sprite. So let's just skip a little bit. Yeah, this is not what we want. This is not what we want. This looks more like the direction we want to go. He's actually doing a whole lot of splitting there.
From right. That's it. We want to fade from both edges. Just tick those. Now we're fading from both edges. This is the concept. Now let's expand it to the top and bottom edge. axis, see, we do fading from left to right. If we choose the green channel, we can see fading from bottom to up. So that's what we will be working on. So let's start by the right, and we want to control the visibility of the game.
Yeah, okay, he's doing the same thing that we do, but he's not oh. He's using it on top of the whole sprite. He's not scaling it yet. Let's see. No, he's not scaling it. So this is useless. So this can still take forever. Let's see what happens if we multiply the UV map. Set everything to 1. And multiply this together with the bar. No change. Okay, we should also use a G value. Let's try again. Okay, instead of trying to change the UV, we can just try to shrink this down. I guess. I guess. So let's put in some math. Let's see what we can do. Multiply. We can shrink and enhance this fade effect, but that's about it. That's not what we want. How we are going to squish this into a smaller matrix? Hey, what's this? Wait. Oh. Yeah, okay. These properties are the properties that we have just defined. Only the tiling and offset function here seems to be promising to me. Yeah, but it's not doing anything. Okay, we only want to edit the y value here. But no matter what we do, it will not work, I guess. Because we are not squishing it. We need to squish it. God damn it. Yeah, like this. Hmm. So what was this again? 1 minus. Mhm. so close and yet so far away. Oh man. Now what I'm doing now looks alright, but it's not what I want. Like this, like the heart looks now like I want it to be. Like you have this, oops, you have this small kind of something things coming out here at the edge, but I have no control over it, mathematically speaking. Or like this. This would also be interesting. Yeah. But now as the rectangle will change its position, as we fade to another position, it's not going to be at the same fading position. And since we also don't know how we can control this much more, much better, this part of the heart here is still not fading out super convenient. If we use another and offset tile, so in the end, we want to have this. What does this have this be applied to this UV map somehow? So let's put it here because we are going to test out what we can do. It's going to put out in the UV map. So putting this into tiling, it's not going to work. And actually, I don't think this was a good idea. Never give up. We can do this. I think this is the wrong way. We have to apply this rectangle. Fair enough. Okay, that's interesting. Hmm. I don't know why it needs an offset. But on the other side, I don't have to care. All I want to do is take this one and this is exactly what I want to have as an end product. Something like that. Let's split this again. I mean, we're doing too much processing right here. So the only problem that we have is it's not moving according to the coordinates that we needed to have. But aside from this right here is very good. So what's the problem? The problem is very simple. We're just applying this rectangle with this version, and we're not moving anything inside of this version when we are moving the rectangle. So this fade effect is not moving with the rectangle. That's pretty much it. That's our problem. Hmm. Oh, this flip book is actually really nice. Can invert Y. Okay, it's not doing what I thought it would do. Okay, I thought it would flip the UV. It doesn't. Fair enough. I don't know what this actually is supposed to do. So I think the best attempt that we have, I think this is a failure right here. The best attempt that we could have is to create this effect out of this rectangle instead of trying to squish this down somehow into this rectangle. Maybe if you use this split on it. Let's see what we get out. Now we get out One value. Hmm. There's only this R value inside. Now we don't have anything that is nice inside of the information of this rectangle that could make us do a fade effect. But if we add this to a UV and put those two together, let's multiply this. Now we have some information that we can work with. Unfortunately, it does not work in our favor. Oh. This is not enough. But before multiplying, we can split this UV. I think it's the only the G that we want. Hmm. No, that's not it. Okay, they say you can just multiply this. And then it will actually scale. So let's see what happens. I suspected the Z and value won't do anything. This will do. How we are going to scale this according to our... Oh, god damn it. It's not really the kind of scaling that we want. I want to try something. Is this rectangle always going to be a rectangle? Which might sound like an odd question. Yep, it is. What the hell? Oof. So let's summarize. We have the exact position of this rectangle here. In this UV. This UV here is what we actually want to use. Man, I'm trying to make any sense out of this. I'm really trying to make any sense out of this. It's really hard. Now I still have one good idea. If we could find a way how to blur this instead of editing it, it would be really nice. Let's maybe search for that. That might be a really good solution, because then we are also having some blue at the edges. So soft edges, yeah, soft edges. Smooth step. Okay, let's look what smooth step does. Because it sounds like it might be a good idea. So, what is this doing? I don't know. I guess we'll find out. Let's set this to 1 first. Ah, I guess I know what it does. Blends those two together. It's not what we want. Not what we want. When we actually plug it in wrong, we're going to plug this in this one. Just fading out. I have the feeling like the edges here are rounded a little bit, but I'm not sure. Let's try to apply this. Multiply. And we can't see anything actually happening. Except that at some point it's starting to fade completely. Damn it, it's not accurate enough. I wonder what the distance does. I don't have any idea. But I also don't have any hope that this will help us. Hmm. What's thither? Hmm. No. That's not what we want. Forget it. Now let's make a matrix. What's the transformation matrix? just putting something out. Okay. So this matrix is our blue matrix. This is some computer science basic stuff. And how are we going to apply this? Let's multiply this matrix with this. Okay. So this actually does soften the edges here. It's barely noticeable, but it really does soften the edges right there. That's all this does. Now we can push this maybe to the limit. If we do this multiple times. Is it possible? No. Let's just do this over and over again until the edges are really soft. It doesn't look to get much softer, but it should. Okay, let's just take this and multiply this. Okay, let's split. We just want to take the green part of this. It's still not enough. Actually. So it did work a little bit. It's way not strong enough. Way not strong enough. it's barely noticeable. And then in the end product, I don't see a blue at the edge. Hmm. And if we don't split, and everything is going to be blurred, it's also not what we want. we're not now trying to watch this tutorial, and maybe it helps us blur this texture. And this is for emission. Ooh. Okay, this is some really fancy stuff for emission, not what we need. Yeah, that's exactly what we want. I don't. Is there something with edge? No. They're talking about a complete different topic there. Hmm. Hey, Fresnel, what is this, and can we use this to our advantage? So it's taking our little object here, What does it do? Hmm. No, I don't think this is what we want to do. I'm not confident that this is what we want. No. This is ridiculous. We have to invert this Fresnel first. Hmm. It looks like this whole thing is multiplied with the rectangle, but in the result it's just applied to the whole space, which is really sad. That's not what we want. Yeah, it's just setting the whole color. Hmm. So with the Fresnel, I think it's only working in 3D space. Hmm. That's not good. I have some different script which had an edge. This is the enemy shader. This one. And let's just look if this might be able to help us out. So let's look into the step component. Okay. Now we can insert an add. No. This. I guess this is useless. Yeah, this is useless. What I did there was I'd have this weight right here. And it's getting its values out of this simple noise. But the step right here is taking information out of the simple noise and then putting them onto the whole body. But in our case, it will be useless. This is so annoying. I have to go to bed soon, but I really want to finish this task.
In this video, we're going to add a little bit of sizzle to our force field with to the dock point where we should see what this looks like on a real object in our game view. So save the asset and let's go back. Instead, let's multiply out the post-processing. So we do need to go back to the editor. Let's save the asset and then go back there. With the default +4, connect the sample texture 2D output into this step node as well. And this time, let's change the in value to something a little bit bigger. Our first step node used a value of 0.2. On this node, let's try something like 0.3. Make a basic math node to subtract the resulting values. Math basic subtract. And we want to subtract the step node with the smaller in value from the step node with the larger value. So we'll probably need to crisscross the inputs here. And let me rearrange the nodes so they make a little more sense visually. And now you'll see that we have a new pattern where we have just some really noisy representation of the edges, almost like fuzzy contour lines. Connect this into our output slot, and that should create a pattern much closer to what our goal was. Okay, save the asset. Let's check it out in the editor. Because our temp shader graph is already using the edge noise subgraph, our scene should update automatically. And now you'll see something that looks more like little glowing embers or electrical sparks. Compare that side by side with what we had before, and you can see the difference is that we're only cutting out the edges from the noise this time. With the HDR color, we can pump up the intensity or just tone it down to your liking. Go ahead and pick a color for a different look, but I may just go back to my boring sci-fi blue. Currently, we're then feed this directly into position these notes by the edge noise as we tweak and inspect values. You can almost see how this would
Well, it might be dumb, but let's look what polar coordinates does. So I first thought Fresnel that looked like really what we wanted, and in the end it was still a downer. I'm still not sure, maybe Fresnel was the right way, but I just don't see how we can make this work. So let's see what polar coordinates does. So we can add in this little hello, can you please edit yourself? We can add in our sprite, yes. Looks like another of those nodes. that will actually be useless. Hey, it looks like the edges are getting blurry. I doubt that this will work in our favor. Like, what can we do with this now? We can do this all over and over again, and will it then be blurry? It seems to have a kind of direction. Now the blur seems to be more distributed. Okay, I can't see blur in the final product. Another time we actually didn't do anything. What the hell? But damn it. Another time that we didn't do anything.
The Legend of Zelda, we made a dot product. Also, we define a new color, and then added this branch to the final result. And this is the final result. Royston has done a very good analysis on the same topic. Go to check it out. The link controls the amplitude color using an add node. We multiply it again by the main color. We took the normalized view direction and added it to a like direction.
No solution found. Now the rounded rectangle version, this is not what I was looking for. I'm still going to use this. So I think it's maybe a better idea. Use this because now we at least have smooth edges. Like this. For some reason, we're not seeing this in the output. Oh, I guess we will not see this in the output too much. We'll see it here in a little bit. Okay. Yeah, whatever. That's nice to have, I would say. It's not essential. Let's go back to our problem. Yeah, actually, I don't want this rectangle form. Never mind that. Because this is just going to distract me too much. Unity shader graph, blur edges. I don't know what this is. Not. What is that? Hmm. I don't get it. Okay, I have no idea what this is. Ay, 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 ay. So let's try the normal vector. Okay. And do a dot product. And I have 0 expectations. It does something. Yeah, but it's not doing what we want it to do. No, it's not doing anything. It's not doing anything. Hmm. This rate we will never finish this. Way over time. So I think that the problem is that most people don't have a way to do this. Hmm. Oh, this also doesn't look like it. I thought. Who would have thought? Um, so let's conclude. We kind of know how we want to do this. We can create a fade effect if you use the tile and offset, power it, and yeah, maybe we should also use the clamped node, because then it's not going to bug out. And reverse. So one step, one minus. Hmm. I wish that there was just some way to put this rectangle here, use it as a UV map, and the moment we do this, it doesn't try to apply itself in a weird way. Like if you do this, put this inside, and we see that it immediately does something weird. I think this is normally for stretching the color on a 3D texture. Nobody talked about what we want to do here. So I'm maybe going to try every node here, and then I'm going to bed if nothing works. I mean, a lot of those shouldn't work, so no hope there. No. A flipbook. Of course, it shouldn't work. A flipbook is interesting. You should keep flipbook a little bit in mind. So it can be useful to shift the UV map after we created it. Okay, that was every single of those. Let's put blend. Now blend is not going to work. it's none of these. Let's close this. There is a spear mask. So let's go into masks. Weird. So I think if we have this UV, for example. Okay, this is the last attempt, and then I'm going to bed. And we flipbook it. Just to have some control about the green space. We use our flipbook. Set the height. Okay. And we only care about the green value. Now we can do some math, like multiply it. So it's getting smaller. We don't see how often it repeats itself. And now if we create add, we should be able to shift this. Yeah, now only this is moving. Only this is moving. And we just have to find out how much we have to move this. Actually, and we have to also clamp and minus step this. So now we can move this with this height meter here. We multiply it further. We can make that this transition is really smooth. And then we just multiply this with our little rectangle here. We have to find the right position. That's it. It's the right position. Still not strong enough. We multiply further. Okay, now the only thing that we have to worry about is to set this height up. So we have done it. We have done it. After so much experimentation, I was just like, okay, let's go to bed, but let's just think about how UV maps work. And try the most stupid and basic things and add them together. Now I don't need to wait a moment. I can just put this in here, and then I can in the end use the add function. No, I can't. Whoopsie doopsie. So I can use the add function to simply adjust the height. So I can set this height to 0.5 or 1. 0.5 seems to be fine. Set it to the middle. Okay, I feel the middle is like in 0.5. Like this. But after we multiply, it's not in the middle. So let's make this higher. Okay. And after that, we're going to add and subtract. I want this to move with the rectangle. And for this, we need... Ooh. Yeah, we need something. Therefore, we need to add something before here. One will be 4.03. The other value will be something multiplied, I guess. And if the paid value. So what is happening if we change fate right now? It's going into the opposite direction. It looks like it's going into the right direction, but after the one minus, we're going into the opposite direction. So we have to multiply it with a minus value. Okay, now when we go into the graph settings and change fate, now we are moving the fate in the right direction. Now let's try to find the correct height. So what should this graph right here? And at this point, we are good. So let's maybe make this a little bit bigger. I want this rectangle to be bigger because a little bit hard to apply effects to it. Okay, so if this is bigger, we can smooth this a little bit. Okay, now. Okay. So if we now play with the fade, we see something weird happening, and that is that in the bottom position it looks okay. There's here this position where it looks as here somewhere. Here it looks like it's all right, but when we are at the top, the rectangle is not following enough. We have to guess this multiplier a little bit more accurate. Also, I'm going to make this to 11. Come on, let me edit you. Thank you, sir. So let's first start with setting fade to 0.05. Okay, this is the default position. And set it up that it looks nice. Okay. Guess this is what I wanted to have. So if I set this to 0.9, let's try to just adjust this multiplier so it looks fine. Okay, it's very nice at 1. If I set this to 0.5, not looking nice. And if I set it to 0.9, 1, it's gone. So what about 0.5? 0.5. It's also not seeming to be correct. I think it's something between 1 and 2. No, it's not. So here it seems to like the value 9. I don't think this will work though. No. Hmm. Let's start again. Let's see what we did here. Hmm. I guess we can multiply this. No, use this value. And first multiply it with our fate. That's weird. Should at least get something if we change these values. Hmm. Let's put fade to 1. Hopefully we don't have to do too much guesswork because we're guessing. We're guessing values right now. Okay, we're getting there. Let's change this multiply a little bit and go back to the top. We want to have it so it consistently looks good from top to bottom. Problem is, when we're at the top side, we want it actually fade out a lot very fast. And I have no idea how this formula works. Okay, I think we need a higher value for this multiplication. So we need to get lower this value. Because then it's generally speaking more stable. Okay, let's get even lower with this value. Now let's get higher with this value. Okay, and we overdid it. So there's a point where we can reach where we can reach parity. If this is bad. Now let's go for 2.8. Okay. To get low with this value. Now with this. It's not 2.8. Maybe 3 will do. I'm guessing too much. I guess this multiplication here is a bad idea overall. It's this one, this number that matters. And we seem to be close with 1. So let's maybe go a little bit smaller. Let's see how it changes. Okay, it likes higher numbers. But not if you go up. Yeah, that looks like we're getting there. Hmm. Okay, now we have our fading effect ready and set up. Let's go a little bit higher and change the actual effect, because that's something that we didn't worry about yet. That this little Voronoi, it is moving. And let's multiply it. Multiply the time scale. Okay, then let's obfuscate what we are doing. It's creating a gradient noise. We're going to add those two. No, we're going to multiply them. And for the UV, we are going to add time. So that the UV of the gradient nose moves. So first, let's just try to straight add time. Maybe not that much. That's not good. Okay, for our noise, we are going to put these out of the group and make a whole new group. And I'm actually going to just straight up copy shader from another graph, because I did this already in a very similar manner, and this means we can just add it from the similar shader. So let's look it up. It was, oh, what was it? Let's look into shaders. Was in the damage UI, the damage UI shader. Now I remember. So in this damage UI, I have a whole system just for generating this random noise. Oh, sorry. And of this shader graph, everything here is for generating the noise. So let's copy this. We could also make this a subgraph. Yeah, let's make it a subgraph. So let's make this into a subgraph. Oh, no, I want to modify it. Okay. Now put this to the side. And this right here is my little output. I'm going to add this on top of the other graphs. We can delete all those little graphs here. I want to increase the cell size. Hello. And so it's a gradient noise scale. think this is a good scale. No, it's to be bigger. I don't know. So I'm gonna switch these. Base is gonna be the Voronoi noise. And the gradient noise is just going to be added on top. I think it moves a little bit too fast. Slow it down a little bit. Okay, and we have a lot of movement here that is generated by all these time scales. But we want to change something. We want to go into the top direction really fast. So for this, let's create UV. And add. Oh, and also time. Multiply those two. So time mult UV. Yeah, I thought it would move. Hmm. So let's plug. Let's plug a little bit. Hmm. That's weird. I didn't think it would go into two directions. That's not correct. I guess it's combining those two. So we can split different. Oh, yeah, it's not going to allow me. Now we're cooking. Now, for some reason, I don't get anything useful of the Voronoi. That's weird. Hmm. I think the Voronoi doesn't like it if we are buying fewer time, because then it's going to be a very high value after some time. I guess that might be the problem. So, So now we have this effect, and it looks a little bit like the health is fading out of the heart. I guess this is exactly what we want. Like that. I don't think this looks too bad. Yeah, then we're done. So, I guess it's finally time to sleep. We have done this this animation very well, I guess. And let's look how it looks inside of the game. See what we changed here. I don't remember that. Not much actually. So let's just save it and call it a day. Now, in the game, how is this shader going to look? See our little heart pulsing already. We're going to set fade to 0.5. And look at that. Ooh. With the background, I think this looks amazing. This looks so amazing. Let's just press play one last time. Save. Press play and look if it looks good with our current animations. After that, I'm going to bed finally. I actually did overdo it today. So with this wobbling number, it's wobbling a little bit too hard, but yeah, I think it's a little funny how much this number is wobbling inside of the heart. Can we put the mode to maximize? I want to see this in big. Yeah. So because it's rather small, I don't want the UI to be too big. It's not noticeable as much. But I think the health UI right now, we still have to do some work with it. But the hardest part is finished right now. This concludes our work for today, and we're going to set the rest up tomorrow. It took a bit longer than expected, unfortunately, but I think the payoff was worth it. So have a good night. Thank you for watching, for everybody who's watching this and the what later, and see you tomorrow.